Welcome to today's lesson. In today's lesson, we are looking at standard form and how to express numbers in standard form. So, numbers in standard form are represented in the form a times 10 to the power n, where a is a number greater or equal to 1 but less than 10, and n is an integer, and n is an integer, and an integer we are saying it's a positive or negative whole number, positive or negative whole number. So I'm just going to look at a couple of examples. I'm going to look at some that are very easy. Let's say we have 1000 and we are asked to express 1000 in the form a times 10 to the power n. So 1000 is equal to 1 times 1000, right? It's equal to 1 times 1000, and 1000 is equal to 10 to the power 3. So this is how you express 1000 in standard form. So let's say we have a number 1258 and we are asked to express it in standard form. So what I want you to remember is this number here is under thousands. It's under thousands. So what it means is if we put a comma there between 1 and 2, we are still going to multiply it by 1000 in order to get the original number, which is 1258. Why? Because multiplication by 1000 moves this comma 3 times to the right, and then it goes back to its original value. So the place values are very important when you are doing standard form or expressing numbers in standard form. So which means the answer here is going to be 1,258 times 10 to the power 3. Let's say we have another number 0,012. So we've got 0,012 and we have been asked to express it in standard form. So by definition we said a should be greater or equal to 1. But if you look at this number here, it's a number that is actually less than 1, which means it doesn't fall in this category. So to make it a number that falls within this category, we have to move the comma to this point here. So if we move a comma and we have 1,2, right? But now the original position of this comma is to the left of where we have put it now. So I want you to understand that. Okay, now we have put it here, but its original position, right, is 1, 2 going to the left. That is its original position. So if its original position is to the left of where we have placed the comma now, it means our power for this 10 is going to be negative. And it's going to be negative how many? 1, 2. Because it's moving 2 times to the left to go back to its original position, which means this becomes to the power to the power minus 2. All right. So in other words, what we are saying is, if we were to express this as a fraction, 0,012 is the same as 12 divided by 1000, because you count the number of decimal places. It's supposed to be equal to the number of zeros in front of 1. Right? So if it's like this, what does it mean? It means that we have 12 over 10 to the power 3. Right? And now we can say, if we find the reciprocal of 10, this is the same as 12 times 1 over 10 to the power 3, and the reciprocal of 1 over 10 to the power 3 is equal to 10 to the power minus 3. And 10 to the power minus 3 times 12, it's not yet in standard form because 12 is greater than 10, but a is supposed to be greater than or equal to 1 but less than 10. So to make it a number within that category, it means it's going to be 1,2 times 10. This is the same as 12, and then we multiply it to 10 to the power minus 3, and this one, I want you to know, it's to the power 1. So now our final answer is going to be this 10 to the power 1 plus minus 3, because when you are multiplying two numbers that are sharing the same base, you add the powers, and since we have got 1 plus minus, it will end up as 1 minus 3, which gives us 1,2 times 10 to the power minus 2. So this long way of doing it is just to show you the other way of getting to it in mathematically, but there is shortcuts to figuring out how to express a number in standard form, like the one that I showed you here above. Because movement of the comma to the right, it means it's a positive power, and movement of the comma to the left, it means it's a negative power. Okay, so I'm going to illustrate with another example. Let's say I have 0,685, and I've been asked to express it in standard form. I have to make this number a number in this range. It should be greater or equal to 1 but less than 10. So if I move my comma to this point, I'm going to have 6,885, right? So if I have 6,885, I'm going to say times 10, but then I need to wait before I put the power, because I need to figure out which direction am I moving to go back to the original position. So now here I'm going to move 1 to the left, and the movement to the left is a negative power, so it's negative 1. I'm going to use this number, but as a whole number, not a decimal. 685. I have 685, and I know this number is under hundreds, right? So if it's under hundreds, it means if I put my comma there, I'm going to say 6,885 times 100 to get to the original value, which is 685, right? And 100 is equal to 10 to the power 2. So it's all about the place values. I want to show you another way here, because we are saying 0,6885, and I want you to know this one, the place value of this 6 is 1 over 10, the place value of this 8 is 1 over 100, and the place value of this 5 is 1 over 1000. So if we are going to say 6,885 here, is the same as we are multiplying this by 1 over 10, which is the place value of the 6, which is the place value of the 6, which are called tenth. And this is to the power 1. And if you find the reciprocal of that number by taking this denominator to the top, you're going to have 6,85 times 10 to the power minus 1. So let's try to do these examples now using the place value of the first non-zero digit that we have in these numbers that we are being asked to express in standard form. Let's say I have 0, 0, 1, 1, 4, 5. And this one, and this one which is the first non-zero digit falls under what? This falls under 1 over 10, and this one falls under 1 over 100. So what it means is we're going to say 1, 4, 5. And what determines what we are multiplying with is this place value, which is 1 over 100, which are called 100th, right? So now this is the same as 1, 4, 5 times 1 over 10 to the power 2. And to find the reciprocal of 1 over 10 to the power 2, you change the power to negative, and you're going to have your answer is 1,45 times 10 to the power minus 2. And here we can prove it, because if we were to move from the new position of the comma, we are moving 2 places to the left, and which is a negative movement of 2. If we have another number, 24,562, and you are asked to express it in standard form. This is the digit that we want. It's the first non-zero digit that we have, which is 2, right? And we have to make it a number greater or equal to 1 but less than 10. So in other words, what I'm saying is this 2 represents 10,000. It represents 10,000. So in other words, what it means is, if you want to express it in standard form, we are saying 2, and we put your comma right after that 2, and say 4, 5, 6, 2. We are multiplying it by 10,000, because this 2 represents 20,000. And if you multiply 2 by 10,000, you're going to get 20,000, right? So now you say 2, 4, 5, 6, 2. And here, how many zeros? 1, 2, 3, 4. So your answer would be 10 to the power 4. 2,4562 times 10 to the power 4. And here, if we are to prove it, we put our comma here. This is where the new position of our comma. But now, if we are going to take it to its original position, when you have a whole number, the original position of the comma is right at the end here. And how many times do we move to get there? That's 1, 2, 3, 4. And which tallies with this power that we are getting here for the power of 10. Okay, I'm going to use another example. Let's say we have 0, 0, 0, 5. Let me change it. Okay, or I can leave it like that. It's fine. It's fine. Let me leave it like that. 5. In standard form, we are saying this 0 is under 10th. This 0 is under 100th. And this 5 is under 1000th, like this. So which means when we pick this 5 as the first 0 digit, we're going to multiply it by 1 over 1000. And if we simplify that denominator here, we're going to get 10 to the power 3. And if we change to find the reciprocal of 1 over 10 to the power 3, we're going to change the power to negative, and our answer becomes 5 times 10 to the power minus 3. And if we were to prove it, we come back to the original number, which is 0,005. Now this is the place that we have put our comma, right? Because now we have got a whole number, which is 5, which means our comma is right after that whole number. And to move back to our original position, we are moving 1, 2, 3 places to the left, which is negative movement, and which is represented by this negative 3. So I hope I have made it simple to understand, and I have also shown you like the long way to getting to the answer. So I just want you to go through the video, go through the examples more than one time if you can't get it the first time, until you understand it. And I will see you in the next lesson. Thank you so much for watching.